Good evening, ladies and gentlemen. I'm Ben Daniel, Chief Editor of Packaging Middle East and Africa magazine. It's a real pleasure to welcome you on behalf of our esteemed partner, Husky Injection Molding Systems, to this highly anticipated webinar. The topic of today's webinar is Innovations in Sustainable Beverage Closures, focusing on lightweighting, tethering, and PET closures. As packaging professionals, brand owners, and manufacturers and solution providers, we're all working in a rapidly changing environment influenced by sustainability goals and new regulations. In this session, we'll unpack key developments driving change and opportunities in the beverage closure industry. So, for our discussion today, we'll be revolving around four pivotal themes. Number one, how material lightweighting enhances both sustainability and production efficiency. And number two, we are going to also look at the growing role of tethered closures in reducing plastic waste, boosting recyclability, and ensuring compliance with environmental regulations. We're also going to look into the future of PET closures and their role in enabling monomaterial, fully recyclable packaging. And last but not least, we're also going to hear from Husky on their innovative approach to optimizing design and manufacturing in cutting-edge technologies. So, we are privileged to have with us Michael White, the Director of Business Development for Closures at Husky Injection Molding Systems. With over 2 decades of leadership in global product marketing and business development, Michael brings deep insights into how technologies are shaping the future of beverage closures. Husky, as many of you know, is a global leader in injection molding systems, especially recognized for its innovations in packaging solutions. So before we hand over to Michael, for all of you who are online now, a quick note about some questions that you may have. So on the right-hand side of your screen, you'll find a Q&A box. Please feel free to type in your questions over here, and do not forget to put your name and your company also. So we would like to know your question a little more in detail, and so that we can also Husky can be in touch with you in the future to help you all the more. So we'll address your questions during this Q&A session, and Michael will be happy to answer them. Now, please do join me in welcoming our keynote speaker, Michael White. Over to you, Michael.
Thank you, Ben, for that warm introduction, and thank you, the viewer. Good morning, good afternoon, good evening from wherever you are viewing this, and thank you again for the privilege of your time. So I've divided our talk today into 3 key areas. The first, talking about simulations and the extensive use of simulations within our business, on how we can leverage that to enhance lightweighting and also promoting speed to market. I will then pivot and talk about tethering legislation, and it's more than just legislation in Europe, as we're starting to see, and I'll explain a bit more when we get to that section. And then finally, we'll conclude the talk discussing PET closure, our learnings, and how it truly enables the circular economy for beverage packaging. So the first section I want to talk about here is how we develop closures here at Husky. It's basically divided into 2 areas. We have the virtual environment and also the physical environment. And we start with the virtual environment, and that essentially is the first step in that is looking at the design itself, sitting with the customer, understanding their needs, their requirements, what type of neck finish they're looking for, type of neural pattern, basically capturing the needs and wishes of the customer and capturing that in a specification form, if you will. What type of tamper evident band they would like to use, type of resin they're planning on using, master batch, and. Once that is defined, we then move to the design stage. And here leveraging our sophisticated CAD tools, we look to start to develop the closure itself, how thick the top panel should be, how much interference should the plug seal have on the inner bore seal on the neck finish itself. Again, the type of tamper evidence used, incorporating the knurls, all of those different features that you see in the closure here. Once we're confident that the CAD design satisfies the needs of the customer needs, only then will we move to our simulation tools. So here we have tools that simulate how the resin, the material flows within the cavity, how it fills out the part, if there's any kind of preferential flow, dead spots in the simulation. And that gives us a good idea on whether or not the design is manufacturable in terms of injection molding. Once we're confident with the flow simulation, we then move to the finite element analysis stage. And here we have different mechanical FEAs that we use to simulate real world use of the closure itself. In the still image shown here, it's showing internal pressures, likely a carbonated beverage, that are acting on the top panel and also acting on the plug seal itself to ensure that there is sufficient sealing capability with that specific design. I want to note in all of these steps, it's an iterative process. So at any point, if we don't like how or we don't see a optimal filling solution with the design, we then can go back to the previous step or even back to the first step, and then rework or rethink how we should modify the design to achieve the proper flow, the proper mechanical performance of the closure itself. And by working in the simulation in the virtual world, you can make those changes much more quickly than you can in a, say, a trial by error environment where you would proceed to, off the bat, cut steel and then realize, oh, that didn't work. Let's get another block of steel and rework that again and start over. So by playing in the virtual environment as the first step, we can rule out issues and address those upfront and enable us to get a quicker approach to market that we have much more confidence in that it will meet the customer needs, the consumer's expectations, and overall help to promote the image, the brand image that the brand owner is striving for. Once we're satisfied that the FEAs satisfy the requirements of the original design intent, we can then move to the physical environment. And this is where we begin to manufacture the pilot mold as the first step. Once the mold is manufactured, we go through our pilot production where we generate pilot samples, submit those to our lab for dimensional inspection, making sure that the closure itself is manufactured to the expectation in terms of dimensional requirements. Once we're satisfied with that, we can then move to the lab performance testing stage, where the closure is subjected to a variety of different tests, whether it's strip torque, secure sealing, drop tests, things like that, to ensure that the closure is meeting the specifications required to perform sufficiently within the environment. And then once we're happy with the performance results, we then move to the line trial stage where we actually validate the closure on the line. And once it passes that stage, we're then ready to proceed to the production closure mold. And this type of an approach is used for all of our applications, whether they're custom solutions or standard off-the-shelf solutions that are reflected within our portfolios of non-tethered and tethered designs. So what does that mean? By having Husky has a portfolio of a variety of different closure solutions mated to industry standard neck finishes for water, CSD, and the aseptic hot fill markets, both in tethered and non-tethered designs. And I'll get into that a little bit later. So that's an overview of our design. Now, let's show a real world example here. We're always looking to, with our portfolio solutions, they're not static. We're always looking to optimize the designs and making sure that they're the lightest weight possible without compromising the user experience. And an example of that, where we are leveraging our simulation tools, which I just explained on the previous slide. Here we're looking on screen at a typical 2925 closure solution. Very, very common in the Middle East for still water, common in Europe and Southeast Asia, really the dominant solution. Now, we will take that closure solution that we've developed, over time. We're always benchmarking against the competition, seeing does it have, is it the lightest weight in the market? By having the lightest weight without compromising usability, you can ensure that the closure is using the least amount of resin possible to still fulfill the expectation of the customer and the consumer in the marketplace. So we'll take a look at this closure here, and we divide it up into all of its different features. So whether it's the top panel here, the plug seal, the outer seal, the threads, the tamper band, the cams, we have a look at all of those different features. And what we do is we run it through our analysis and say, okay, is there waste in that specific feature? So for example, we'll take a look at the cam. We'll say, is there waste in that feature? Meaning, is there excess weight in the feature itself that we can remove? And here we're talking, tenths or hundredths of a gram. When you're producing millions of these closures, that adds up. That's significant. And we want to make sure that we're producing or developing the lightest weight possible without compromising performance. So we'll have a look at the cam, for example, and say, okay, with the design, with the weight of that feature, can we scrape out a few hundredths or even a tenth of a gram in that feature? We'll then work the design to scrape out or pull out that said excess weight or waste of material. And then we'll subject it to our flow and mechanical simulations that I described on the previous slide. Once we're confident in the results that we're getting through our FEA simulations, we'll then go back to the manufacturing and test stage, and then that helps us get to right the first time and helps to promote the speed to market. A real world example here is what's shown here now on the next slide. So we applied that same methodology to the closure on the left. So what you're looking at here is a section of a PCO 1881. So a very common closure design that's used in carbonated soft drink type applications. And we said, okay, we want to minimize the weight on that design, but also add a tethering function as what's shown on the right. So we used this as the baseline and said, okay, we want to modify this design, lightweight it, and incorporate a tethering function. Because most people assume that, okay, if you're adding functionality to the closure, you're obviously adding weight. And that is kind of counterproductive to what the original intent or spirit of the tethered legislation that was passed in Europe is. Really, what you want to do is ideally incorporate a tethering function and not add any weight. And that's really what we've achieved here. So we looked at all of the different features that make up the closure itself, and we said, okay, what can we take out of the plug seal? What can we take out of the outer seal? What can we take out of the top panel, the shell? And incorporate that tethering function. And by the way, we can't add any weight. So that's really where we challenge the design team on coming up with a solution that addresses added functionality to comply with legislation without adding any weight. And the result was we actually saved 0.1 gram on the closure itself, plus added a tethering function. And we applied this same methodology to our entire portfolio of closure designs. So the water, CSD, and the aseptic hot fill solutions. Here now, when I talk about portfolio, this is essentially what I mean. We're looking here at our water, CSD, and our aseptic for juice, sport drinks, and teas applications. So these are closure solutions, industry-leading weights, mated to industry standard neck finishes as provided by the SETI organization and also the ISBT organization. So two global bodies that are managing industry standard neck finishes. So these closure solutions are all optimized for those specific neck finishes in the marketplace. So we have a variety of solutions for still water, for CSD, and also for juice, sport drinks, teas. So again, we apply that methodology on ensuring that we remain industry leading in terms of our solutions that we offer to the market, and without ever any license fees associated with that. So these solutions are available, tested for a variety of different material and master batch combinations available off the shelf. I want to switch. So now that we have the baseline on how we approach design for closure solutions, I want to talk a bit about our tethered approach. So I think most people are familiar with the tethering, but just a quick, brief introduction. It was legislation that was passed by the EU back in March of 2019. And it is a broad piece of legislation covering everything from single-use, any kind of single-use plastic item, including cutlery, so your plastic spoons, forks, knives, plastic straws, fishing lines, coffee stir sticks. And another element of that is also mandating increased use of recycled content like rPET in beverage packaging bottles as we move through out to 2030. I believe this year in 2025 in Europe, it's requiring 25% recycled content, and then it moves up to 30% out to 2030. So again, designed to tackle single-use plastics and how do we make them more sustainable. The area that I want to focus on is the tethering aspect. And so while the legislation was introduced or passed by the EU Parliament back in March of 2019, there was a 5-year period where designers, closures, equipment providers, and closure solution providers had to develop tethering solutions. So what that means is if you're a brand owner or a converter looking to sell into the EU, since last July, you need to ensure that your single-use beverage package that is 3 liters or less has a means of tethering the closure and ensuring that the closure is tethered to that bottle. There are strict requirements too, like a 25 Newton pull force. The closure needs to withstand, the tethering system needs to withstand 15 openings and closings. So it's a lot of initiative in the with the end goal of minimizing any kind of terrestrial pollution in the natural environment. Now, this is legislation in Europe. We're also monitoring, from a global perspective, other geographies where there may be legislation passed. And right now in the US, there are tethered proposals that are being offered up by senators both in the state of California and the state of Illinois. So these are not passed yet, but you can see that the tether legislation in Europe has started to create a bit of a domino effect in other geographies. So, meaning California, the state of Illinois are the first to look at in the US possible passing of legislation. And most of, like, all of the designs have already been created. So there are solutions available that can just plug and play right into those pieces of legislation, whether it's in the US, what's in Europe, or even other geographies that may decide to pursue tethering in the future. Just a quick highlight on our tethered solution, and this patented design is was designed with the intent, one, to remain weight neutral, but also to enhance the consumer experience. And just how it operates here, you have three simple elements. You have these arms on either side of the closure that are connecting the tamper band to the actual shell. And so as the closure is unscrewed and then flipped over, this hook actually compresses against this flap. So you have this action here where the shell is compressing against the neck finish itself, or against, sorry, the tamper band and the flap itself. But then these arms are actually acting in tension as well. So combined, they help to provide a what we consider a superior consumer experience. So you have that audible click as it snaps into place, and then the shell is locked into place. So it's not interfering with the consumer as they're going to um, either drink directly from the bottle or pour in the contents into the package itself. So, number one, you're avoiding interference with any facial features on the consumer itself, him or herself. Is very intuitive on how to open. So unscrew and then snap over to lock into place. And then you're given tactile and audible cues as that action is performed. And then finally, it's also a means in areas where there isn't legislation for brands to further differentiate themselves and create a story around sustainability. Now, here, similar to what I showed on one of the previous slides related to our dynamic portfolio, we have also developed the similar portfolio for tethering. Again, applying that same methodology where we're always looking to optimize the solution in terms of removing weight from the solution itself. So we have a portfolio of closure solutions for still water, CSD, and also on the aseptic and hot fill sides as well, both in the 180-degree opening and the 160. Now, one of the things that we've seen more entrepreneurial thinking brands pursue is incorporating tethering into their brands in geographies where there isn't any legislation mandated. So two examples that I want to show here are brands that are based in Southeast Asia that have looked at tethering as a means to help differentiate their product and take that sustainability messaging and incorporate that into their storytelling. And that really helps with top of mind thinking and educating the consumer on why they're doing it. So the first one is Nature Springs in the Philippines. And here they have a little video that you see here on TikTok that describes their spring water solution and then also their tethering solution. So this is using a Husky solution. And you can see here they're educating the consumer on how to use our tethering solution. The next is Rare Beverage, based out of Thailand. And here you can see similarly, they're describing the tethering function itself and how it works. And again, a brand can create a whole story around the tethering solution and help promote their brand in terms of sustainability and also usability, enhancing their usability. I don't know about you, but I know in my family, my wife always tends to lose her closures when she's opening them. This is another way of ensuring that the closure remains on the bottle itself. Again, is a bit of a snapshot on where we've have installations of tethering solutions that outside of Europe. So again, um, the legislation is passed here, and you can see that there are brands outside of Europe that are incorporating and embracing tethering as an option. So I want to switch gears a bit now and talk about our PET closure solution and how that enables the circular economy. So when we think of a circular economy, what is it? It's really a model of making, using, and then recycling a product. In our example here, we're looking at beverage packaging. So you typically have, your PET bottle with a HDPE cap. Now, there are well-established streams for PET that exist today. It's the most recycled resin on the planet. Um, Recycling is well established for the bottle. On the HDPE side, when it comes to beverage packaging, that material is typically downcycled. So it's taken out of this circular loop and downcycled into other non-food contact applications, whether they be pails or lawn furniture, things like that. And that requires then a fresh injection of new material into the circular loop. Really, the holy grail is to have an entire package manufactured from PET to take advantage of that existing recycling stream and keep that material within the circular loop of the PET stream. And that's really the holy grail, sorry. So the real challenge here of the closure is to preserve and protect the consumer. So what function does the closure provide? It really keeps the bad stuff out and the good stuff in. What we've developed here with a PET closure and our solution is what we consider the industry's most secure TE system. And I'm going to get into that now. So when we started down this path, we said, okay, let's see if we can inject our mold, the typical mold, with PET and see how it performs. And what I've captured here are X-rays within our lab as the closure is actually applied to the neck finish at different intervals until the closure is fully applied to the neck finish itself. So you'll see in the first step here on the tamper band, we're looking at this area here, highlighted in the red um, um, box here. So as the closure's rotated, it is applied then to the neck finish. These cams here, as shown here, then make contact with that pilfer proof as what is shown here. So as those cams make contact, requires the band and the bridges to stretch and deform over the pilfer proof until that cam has fully passed and it's then returns to its normal shape. So there's a certain amount of elasticity that HDPE has in the material that allows it to deform and pass by over the pilfer proof itself. When we tried that with PET, injecting and then applying our first closures onto the design, keeping the design as is, what we found is the material is not as elastic as HDPE. So what happened was the bridges began to stretch and obviously shattered. And with that, you cannot have a application where you have these broken bridges. It's not an acceptable package. So any kind of broken bridges on a beverage packaging, that is considered a reject. So really the contradiction became is okay, you want to have minimal interference as you're applying the closure so that you're not stressing the bridges to the point where they're beginning to fracture. You need to have a certain amount of elasticity, but yet the contradiction remains that on the first opening, you want to have maximum interference with the interaction between the cam and the pilfer proof so that the bridges do break. And there lies the contradiction. How do you minimize any kind of interference on application? And how do you maximize the interference on first opening? It's not like you can re-inject cams or the folded portion of a band onto the tamper band after it's already been applied to the neck finish itself. So that's kind of where we were at and said, okay, we're at a wall that we need to solve this contradiction. And how do we achieve a good tamper evidence without any kind of capping window? And really, the solution lies in our TE forming device. So you're looking at here a prototype design that we showed at NPE last year in Orlando, Florida, and demonstrated to consumers how that works. So this device is actually positioned at the end of the capping line. So as the closure is applied to the bottle after it's filled, it then passes through this device where a high heat source, energy heat source, is directed at the tamper band to effectively form it around the pilfer proof, providing 360 degrees of coverage. This design here that you're seeing is a prototype, as mentioned. It is capable of 15,000 bottles per hour. So we realize, okay, that is nowhere near what's required for an industrialized solution, where filling lines are running at speeds of 45,000 bottles per hour up plus up to, in excess of 100,000 bottles per hour. So what we wanted to do first is, can we get this to actually form a band around the pilfer proof itself? And if yes, okay, how do we scale it? And so this was the solution. So we had that, as I mentioned, at NPE, where we were actually passing through bottles on demand and then sharing them with consumers or attendees of the show and allowing them to interact with the closure itself. So how does it work? This here is a short video that shows that was taken in our lab that shows how the forming actually is performed. So again, no changes to the filling line itself. You have your bottles filled. The only thing that may change are the capping chucks, and that's no different than today with HDPE applications. We always want to ensure that the chuck itself is optimized for the closure and that good interference fit. So again, no changes on any of the change parts except possibly the capping chucks. So the closures were through the cooling conveyor, passed on to the pickup plate, as you see here, as the capping chucks are picking up the closures and then applying them here at full speed to the bottles themselves. Here it is slowed down, so you can see it in a little more detail. Once they are, okay, I'm just gonna back up 1 second here. So here you see as the bottles are filled, caps are applied, they're then passed through on the conveyor through this device, which then forms the band, the bottles, the formed and filled packages come out the other side where they're ready for palletization and any kind of label application, and then palletization. So you can see here, these are the unformed as they're then passed through into the device where the band is then formed around the pilfer proof on the neck finish, providing 360 degrees of coverage. So we have to walk before we run. We are focused today on non-carbonated, non-pressurized applications, so still water. And then as we finalize the solutions there, we then work our way through to the more challenging applications, eventually achieving the CSD solutions, which, as is shown in one of the earlier slides on the mechanical simulation, provide much more challenges in terms of sealing performance and venting because think of them as little scuba tanks. They're pressurized up to 5.2 volumes of CO2. It's a much different world than still water. However, we are confident that we will get there. We need to focus first on fine-tuning the still water applications, and then as we work our way through to CSD. Now, one of the things it may be counterintuitive is lightweighting opportunities that exist with PET. PET material is denser, has a higher weight density than HDPE, somewhere around 35 to 40%. So again, by nature, it is heavier than uh, uh, an equivalent HDPE. Now, what I wanted to stress here is that the properties of the PET actually enable lightweighting opportunities. So the example here, if we just focus on this side first, you have your typical 2925 application as shown here, wide mouth still water application. You have a 3-star thread that typically incorporates 180 degrees of coverage. So 3 threads with a thread length covering 180 degrees of the neck finish itself. Taking the lightest closure that we have in our portfolio for 2925, it's about 1.15 gram. You end up with a weight, dispensing system weight of just under 3.6 grams. So that's for the neck finish itself, plus uh, the closure. It's the closure. Now, because the material PT is much more rigid than HDPE, you can reduce the thread length significantly. So in this example here, We no longer need 180 degrees of thread coverage. You only need 100 degrees to achieve the same level of performance. What does that mean then? I talked earlier about eliminating waste. If we look at the green dash lines here, that area in between those two lines represents waste. There's no more need, and there's no need anymore to have a full 180 degree of thread length. So we only need 100 degrees. So what that represents is approximately 3 millimeters of height in terms of expressed in terms of the closure finish itself that we can simply remove. By removing that, we reduce the height of the neck finish itself, and by association, the height of the closure, resulting in an overall lighter dispensing system weight when we compare it to the incumbent, which is the standard 2925 with a standard closure design. So by reducing that anywhere between, as shown on the graph here, 0.67 to 0.82, depending on what closure design you go with, that represents a significant weight savings when you're producing millions of these packages on an annual basis. And it is so light, in fact, that when we start to look at the 3-start 2622, the GME 3028, which is a smaller diameter neck finish itself, as shown on this package here, you can see the diameter difference. With a PET solution optimized, you can actually achieve a lighter overall dispensing weight, as shown here, versus the 2622 shown on the right. So what does that mean? That means in the still water segment, there is a tremendous amount of runway for additional lightweighting um, and achieving an overall all PET dispensing solution. One of the other benefits of the PET solution is there is a very clear tamper evidence uh, reaction upon first opening, as I will demonstrate now. So here we look at a typical formed solution. So the band has been formed around the pilfer proof. Very clear that you can hear this as the first opening. So I have a formed solution here. So I'm going to open. I'll put it next to my mic, so hopefully you hear it. So very clear opening. It's some of the applications when you look at commodity type water applications on first opening, you're wondering, did those bridges break? I didn't even hear anything. I didn't feel it, right? It's unmistakable when you open that you hear it. You have a tactile response. You can actually feel that those bridges are breaking, and you can visually see that the band has dropped. So again, a industry leading solution for tamper evidence for the PET closure. So we're working on validating against a variety of different resins. Um, you know, Similar to our HDPE approach, you don't just validate a closure solution for one type of resin or one type of resin and master batch combination. You always look at, based on markets, there can be different applications where a customer is saying, well, I don't work with a resin supplier X, I work with resin supplier Y. So again, this is a never-ending initiative where we are continually evaluating different resin types, PET resin types for our portfolio and custom solutions of closure offerings. So again, if you say you are based in the Middle East and you prefer to work with SABIC, we have solutions that we've tested for SABIC. If you say are based in the US and you prefer working with Indorama, we have solutions working with Indorama. Our key partner where we started all of this with is Alpac. So we have a wide variety of resin solutions available for Alpac at the present time. And again, we will continue to develop these solutions as we work through over the coming months and years. Some of the other advantages, in addition to the tamper evidence and the lightweighting, is package differentiation. So you have those glass-like properties on the closure itself, similar as the bottle, that can give new ways to help differentiate your product on the store shelf. Some advantages through versatility with the top panel. You can see through, you can still have a flat surface on the top for the consumer, but then all of your logo and details can be embossed on the inside of the top panel and still see through on the top of the closure from the outside. So more versatility from that side. So in summary, I just wanted to highlight again the monomaterial package is a reality. It is no longer a dream. We're using the same material types as is used in our preform manufacturing. So you can truly have a true circular package manufactured from the same material. The closure and the bottle manufactured from the same grade of PET. Again, the tamper evidence solution here is the industry's most secure TE approach that we have seen in the industry, helping with counterfeiting and also safety, promoting consumer safety. Again, it closure design, same form factor, so same form in appearance, touch and feel, keeping the bad stuff out and the good stuff in. And there's also additional runway for additional lightweighting opportunities as shown in the slide here and described on the previous slide. So just want to summarize then who Husky is, global reach in terms of our manufacturing facilities in Canada, in the US, in Europe, in Asia Pacific, 4,300 team members strong, almost 500 customer-facing support personnel based wherever your molding operations may be, whether it's in Africa, Middle East, ANZ, Latin America. We have on the boots or on the ground, boots on the ground, service personnel to support your operations. And who are we? Solutions provider, system solutions provider, meaning the entire work cell is supported and offered from Husky Technologies, focusing on the closures, the PET, preform, and the medical industries. Wide range of tooling solutions, standalone tooling for both preform, closure, and medical, and also our third-party hot runners. All of this is supported by our Advantage Plus Elite proactive monitoring package, ensuring that we're addressing any kind of molding issues that may crop up in your operations before they become a real issue. So I want to invite you all to come to DrinkTech in Munich in mid-September. We will have an industrialized solution of our PET forming device present there at the show, and I'll be there to answer any questions that you may have. And I look forward to introducing our solutions to you and meeting you and discussing your specific packaging needs. So with that, I want to conclude the talk today. Again, thank you for the privilege of your time. and I'll turn it over to Ben to go through the Q&A session.
Thank you, Michael. It was a wonderful, insightful presentation. It touched on all the important points on lightweighting and tethering and also the PET closures. Over here in the Middle East, certainly all these are important areas as we have converters and also brands focusing on all these important points. And it's very interesting. We have a lot of questions coming in, Michael. So if I may just address some of the important questions which are coming in. I'll start with Murali Krishna from Future Plast from Abu Dhabi. He's asking this question: good to see the developments made on PET closures. Is there any work being done to use rPET material to produce closures to close the loop with complete sustainable solutions with rPET preforms and rPET closures?
Yes, it's a very good question. We have evaluated one rPET material at the present time from RCS out of Germany. But again, I think the IV was around zero point 0.8. But again, as I mentioned earlier, this is an ongoing, never-ending process. So if you have a specific rPET grade that you would like for us to evaluate, feel free to send us the details.
This is question from Alain Farms Noorul Amin. Is it possible to modify the existing injection mold 38 millimeter conventional cap to tethered caps?
It depends specifically on your application. There are, when we, if we know upfront from the design that a tethering is potentially required in the future, we would then design it with what we call tethered ready. So meaning the application would only require the swapping out of the slides, which form all of the tethered features. If the mold was not designed originally with tethered ready in mind, and this is a recent introduction, we could look at your specific application and see what change parts are required.
Right. Okay. Noorul Amin asks another question. This is very interesting. PET caps solutions. Is it the same grade and IB as ISBM PET resin? What is the scalability rate of this innovation in current Middle East market?
So right now we're at the early adopter stage. I would have to take offline. If you could
Right.
send me the details on that one,
So,
because again, we are standardizing using preform grade materials for all of our validation. If there is a specific grade, we can look at incorporating that in. If you could have if you could send me the contact
I will.
info of that person, I will reach out to you, I promise, this week,
Sure.
and resolve that.
Sure. Thank you. Another question coming in from Almarai. Kanan Shahidi from Almarai is asking this question. How do you define a circular economy in the context of beverage packaging? And what role do closures play in achieving this vision? Interesting question.
Yeah. So at a high level, when we're saying circular economy, we'd like to see, you know, no material waste. So that material that was in your 29-25 bottle today is then, and closure, is then in a different package at some point in the future, whether it's, a month from now, 6 months from now. But when we look at the circular economy for that beverage packaging, we like to see 100% of that material stay within that loop and not either, discarded into the local trash can, or discarded into the natural environment. We'd like to see that that is 100% circular. So by having our PET closure solution, um, that is a step towards achieving more circularity. Whereas with the conventional HDPE approach that exists today, that closure is typically then downcycled into some other non-food contact application. And, you know, when you think of in its purest sense, that circular um, approach, that circular loop, that material, a portion of that material, meaning the HDPE closure, is taken out of that circular loop. It is recycled, hopefully, it is recycled, but it is taken out of that circular loop and requiring a new injection of material to complete, you know, the forming of that closure.
Okay, thank you. Thank you, Michael. There's another very interesting question, something which I also had the same question in mind. Can a converter use the same injection machine to produce preforms and closures with PET material? Murali Krishna is asking this question.
Yes, that's a very good question. And I should have had a slide on that. I apologize. Yes, so we are looking at that. So if we look at all of the different material, or sorry, pieces of equipment required on the closure side, yes, if you have an existing, let's assume the high cap. You have a high cap machine. The only thing that we see right now in all of our validation that's required is a new screw and some software updates. So it's a minimal invest on the machine side. On the mold side, you're we unfortunately the because of the different shrinkages, if say you had an existing high cap mold, you wouldn't be able to reuse that. You would need a new stack just because of the different shrinkages. And obviously, you know, the TE band design is different.
Right.
So, you know, the outer cores, those sort of things in the stack would need to be replaced. And also on the hot runner side, our HDPE closures are using a hot tip, a thermal gate hot runner. With the PET solution, we use valve gate, just like we do on the preform side. So on the tooling side, unfortunately, new investment is required. And then
Right.
there is the need, because the PET material is hygroscopic, we need to dry that material. So we need a drying solution, which isn't required for HDPE. And then obviously the forming device. So there are a few pieces of equipment on the tooling side, a new mold, dryer, and forming device. But on the machine side, it's minimal amount of invest to swap over to process the PT closure. And on any of these questions, if you would like more detail, please just reach out to Ben. I have my email address there too. Just remember, just staring at it here. Please send me an email, and I promise I will get back to you this week. Either we can have a follow-up call or email exchange.
Wonderful, wonderful. Michael, thank you so much. These were very insightful details. Participants this evening, I'm sure they all have got some very good takeaway with them to apply, and many questions that they have about sustainability when it comes to closures have been answered. Of course, there are many more questions coming in, Michael, but as you said, certainly we're going to send these questions to you for you to answer them. We'll connect these people with you. This clearly shows the interest in the Middle East for sustainability. You
Yeah,
know,
no, and I want to thank so these were great questions. So I
yeah.
want to thank the attendees today for taking time out of your busy schedule to learn a bit more about what we're doing here. And please reach out to me. If I don't know the answer, I will be sure to involve the people that do.
Certainly, and Michael, I think most of the people who are attending here, they are all experts in their field, especially when it comes to closures, and they all, most of them would definitely be there at Drink Tech, I suppose, and I'm sure that they can see it live, and seeing is believing. I think it's more
Sure.
action, over there. So, ladies and gentlemen, once again, big thank you from our side as well, from Packaging MEA and from Husky, for joining us and for your valuable time. And this presentation obviously will be shared with you as a link. You can again listen to it later if you like to. Questions over here, certainly we're going to give it to Mike for him to get back to you. And we'll also be in touch with you. So looking forward for more such insightful presentations from Husky. It's really very important for our region as we are slowly moving from a linear to a circular economy, and PET being one of the most important areas when it comes to circularity and closing the loop. And it's really happening, Michael. I can say that for sure. In this region, we are easily finding more than 5 to 6% of PET already moved into the rPET space. So that's a very good percentage.
Hmm.
Without implementation of policy and regulation, in place. And just imagine if the policy comes up, how well this will be addressed. So, I mean, there are innovations that you've just shown on the caps and closure side for circularity, and I'm sure this is going to help our region to move towards circularity with Husky's help. All right. Thank
Thank
you.
you. Thank you, Ben. Thank you. And again, thank you to all of the attendees today. I really appreciate the feedback. Thank you.
Thank you, Michael, and thank you, one and all. And we'll stay in touch soon, and hopefully, we'll have many more such insightful sessions from Husky. Thank you.
Thanks.
Good
Thank you.
evening, everybody. Thank you.